This is going to be the first video out of 2 for topic 3, writing function rules. So if we look at this nice drawing of boats with the smoke coming out of the pillar, stage 1 has 1, stage 2 has 2, stage 3 has 3. So if we want to know what stage 4 looks like, it looks like it's increasing by 1 every single time. So stage 4 is going to have 4. So stage 10, now if we look, stage 1 has 1, stage 2 has 2, so we can say stage 10 is going to have 10. Now let's look at creating an input-output table. So I always like to include 0, and then 1, 2, and 3 are included in the diagram. So 1 again has 1, 2 has 2, 3 has 3. So if we follow the pattern, that means 0 is going to have 0. So if we look at what our equation is going to look like, we have to first find our common difference and then plug it into our slope-intercept form. So m is our common difference, so the number it either increases or decreases by in the y's, and b is our 0 number, so that's the y value when x is equal to 0. So if I want to plug in the common difference, it's positive 1, that gets multiplied by x, and my 0 number just happens to be 0. So if we want to write that in a more mathematical way, it's just going to be y equals x. We don't need to write plus 0. Our second example, 2 butterflies take 14. 3 butterflies take 21. So it looks like I'm multiplying my number of butterflies times 7. So 4 times 7 is 28, 10 times 7 is 70. Let's make our input-output table, again including 0. And then 1 had 7, 2 had 14, 3 had 21. So it's looking like we're going up by 7 every single time. So that's our common difference. So we have y equals 7x, and then to find our 0 number, we're going to go backwards. 7 minus 7 is 0. So we can write plus 0 for our 0 number, but we don't really need to write that. So let's look at this table. 5, 6, 7, 8 for number of leaves. So it looks like we're increasing by 1 every single time. So we're going to continue to increase by 1 and fill in those missing values. Now let's write our equation. So our common difference is 1. So we've got y equals 1x. Now we have to look at our 0 number. So we're going to go backwards to 0 number of months. So that means we're going to subtract 1. And 5 minus 1 gives me 4. So positive 4 is my 0 number. Again, I don't have to write the 1, so I'm going to erase it and just keep it as x. The 1 is insinuated. So if we are already given a table, we got to come up with the function rule. So let's look. Our outputs are increasing by 1 every single time. So that means our common difference is 1. And then if we go look for the 0 number, well, when 0 is the input, 2 is our output, so we have plus 2 after that. So there's our answer. The second one's a little bit tougher because we're going up by 1, but wait, our input's going up by 2. So let's start over, and I'm going to fill in those missing x values. 1, and so that means the number between 0 and 1 is 1/2. 3, the number in between 1 and 2 is 1.5. So that means I'm really going up by 1/2 each time. So there's my common difference. We have to be really careful about those. And then my 0 number is already in the table. The output is 0 when the input's 0, so I can write plus 0, or I don't need to. So I've got y equals 1/2 x. Go ahead and do the U-tries.